Hi there. Welcome to our first virtual lab. This one is called Understanding Density. So before we begin, let's talk just a little bit as a refresher about some parts of density that we're going to be working with. First of all, remember that density equals mass divided by volume. And in this lab, we're always going to be working with liquids and solids. And for liquids and solids, our units for density are going to be in grams per milliliter for liquids or grams per centimeter cubed for solids. Okay, now these are the same. And you should be able to remember from our first week's lessons that 1 milliliter is equal to 1 cubic centimeter. Okay, now one of the things that you might need to know when you're working with a solid, okay, is you might need to know some ways to find volume. So let's just go ahead and list that. And this is a geometry thing, which many of you I know haven't had in a long time. So volume of a sphere is equal to 4/3 pi r cubed, where r is your radius. The volume of a rectangular solid is equal to length times width times height, okay? And last, the volume of a cylinder, and that's what we're going to be working with today. You'll be able to see these more when I stop sharing the screen. But the volume of a cylinder is equal to the length or the height of the cylinder times pi r squared from the circle at the top. Okay. In each of these, you want r, radius, to be in centimeters, and you would want length, width, and height to also be in centimeters. Okay, so understanding volume is really important for understanding density. All right, so what we're going to do is we're going to go back to the main screen. And we're going to start working through our virtual lab for density. All right, so now looking at part 1, you're going to have a couple of different objects, okay? Now you can see this one here. It's kind of a, silvery color, and I have identified this one as object number 1, okay? And you can see the cylinder for this, okay? And what you're going to need to calculate volume in a couple of different ways. Okay, so actually what I'm going to do for just a moment is I'm going to open up a chat window, and I'm going to put some information into this chat window, and you'll be able to work through some of this. Okay, so first of all, for object number 1, the diameter of the circular part here is equal to 1.25 centimeters, okay? And remember that the radius is half the diameter, okay? And the length is equal to, I figured these out ahead of time, 4.9 centimeters. Okay, and you're going to be using that because you need to calculate volume in 2 different ways. You need to calculate the geometrical volume, and I showed you how to do that just before we came here, And you're also going to be calculating the water displacement volume for both of these. Okay, so I'm hoping that you can see this. The first thing that we're going to need is, I'm not sure how well this is going to show up, but I will put it in the chat as well. Okay, so I put my object number 1 on the scale, and it tells me 17.4 grams. Okay. So I will put that in here also. Mass equals 17.4 grams. Okay. Now what we're going to do is we're going to do water displacement for our object. And when we work on that, I'm going to go ahead and see if I can lower this so that you can see this a little bit better. Hang on. 1 second. Sorry about that. All right, let's see. Does this lift it up a little bit better? It does. Okay. So I'm just trying to make things easy to see. Okay. So, and don't worry, again, I will put all of this information in there as well. All right. So first of all, in order to do water displacement, we have to fill this, and I'm going to just raise this up for now. And what I'm going to do is I'm looking at this very carefully, because you don't have to have it be exact, but it's a lot easier if the water in here is at kind of an exact level. And I kind of, here we go. Okay, so I am right now at 10 milliliters, okay? And so the volume of the water then you would put in at 10 mLs, okay? Okay, now what I'm gonna do is I'm going to take my object number 1, and I'm gonna very carefully add it to my water. You have to be really careful, because you can actually end up dislodging, you can actually pop the bottom off of these graduated cylinders if it's got too much force. Okay, so let's see how well we can see this. And I'm just gonna try to kind of create a background so that it's a little bit easier to see where we're at. Okay, so you can see on here, I know it's real, it's actually difficult for me to kind of show this. Okay, so each one of the tick marks here is at 0.5, okay? And so if that's 15 and 20, that means halfway between the two would be 17.5, okay? So I'm going to look very carefully. And so it's hard to see the bottom of the meniscus here, but if I look at the bottom of the meniscus, there we go. Actually, that shows it pretty well. 1, 2, 3 up. So that shows it at 16.5. So we'll say total volume equals 16.5 milliliters. Okay. And then you would find the volume of your object, okay, as the total volume minus the volume of the water. Okay. So volume of object 1 equals total volume minus water volume. Okay. And now you have everything that you need to calculate the volume in 2 different ways and to calculate the density. I'm just making notes here for myself, and to calculate the density for object number 1. Okay, so now let's take a look at object number 2. Again, I'm going to try this. Okay, and you might not be able to see it very well, but it says 54.0. Okay. Oh, beforehand, let me go ahead and say now object 2. Now, these are actually the same size when I find the geometry. So the diameter that I found for this was 1.25 centimeters, and the length of the cylinder is equal to 4.9 centimeters. Okay, so again, you'll be using the readings for the cylinder, for the volume. Okay, when you're calculating that. Okay, now let's go ahead and do water displacement for that. Oh, I forgot to put in the mass. Okay, so, and the mass of this was 54.0 grams. Okay, all right, now let's go ahead and we're gonna do the water displacement again. And I will see how close I am to 10. And that looks pretty good. Okay, so again, I'm going to slide this in very, very, very carefully, especially because this one is so much mass. And then let's go ahead and see if we can, I'm trying to, it's harder because everything is mirror image. So let's try to look behind the, see if we can find the bottom of the meniscus. There we go. 1, 2, 3, see? 1, 2, 3 tick marks up. Okay. So again, the volume of my water was 10 mLs, and the total volume is also equal to 16.5 mils. So that's really great in a way because we should have gotten the same thing for both of them, and we did. So that's excellent. You can also see that's the benefit of starting with 10. All right. So now you have everything you need to do part 1. Okay. Okay, so you have everything you need to do part 1. Now what we're going to do is we're going to take a look at something a little different. We're going to look at water density. Okay, and I just have a lightweight cup here. Okay, and I have this. It's a medicine cup from like children's Tylenol. This one's children's cetirizine. I have a child with allergies. Okay, and okay, and then I have here a disposable pipette, and I have an actual pipette and a pipetter. So if you were in the lab, you would be learning to use all of these things yourselves. And so it's kind of disappointing that we're not in the lab, but I suppose this is better than nothing. Okay, so now let's take a look at this. We're going to be finding 3 water samples. Okay, and I'm gonna go ahead and just type in part 2. Okay, and we'll go water sample 1. Okay, and we're going to be starting with this pipette. And here I have some water. Okay, now the way a pipette works is you have to measure it all the way up, preferably to 0, and then down, because the tip in a pipette, let's see if I can get this to show, and I can't at this angle here. The tip of a pipette is not graduated, which means that there's not an exact quantity here, okay? It's not, it says 10, but you can't assume that this is a whole mil, okay? So first of all, let's, what I'm going to do here is we're gonna start with this. Okay, and it might be difficult for you guys to see that, but then I'm gonna turn it on with the cup here, and what that does is it zeroes it out, okay? And now I'm going to start by drawing water up my pipette. Okay. Right to 0. And then I'm going to very carefully release 3 milliliters of water onto my balance. Okay. And I don't know if you can see that or not, but it says 2.9. So my mass is 2.9 grams, and the volume that I found was 3.0 milliliters. Okay, so I'm going to go ahead and put that into the chat. So we'll say water sample 1 equals 2.9 grams and 3.0 milliliters. Okay. Now we're going to do it again. But this time we'll go ahead and use So what I'm going to try now is using more. So we're going to go up to 0. This is more difficult than it looks, probably, or maybe it looks very difficult. All right, let me try going all the way up to 0. And now I'm a little bit under 0. So I'll go a little under 5. Try to aim for exactly 5 mLs. Okay. Good. And now for sample number 1, I measured out 5 mLs, and actually it tells me 5 grams. Okay, so let me go ahead and put that in. Water sample 2 equals 5.0 grams and 5.0 mLs. Okay, now we'll go ahead and take a look at water sample 3. And I'm just going to go ahead and not change where this is right now. I'm gonna go back up to 0. And I'm gonna go all the way down to 8. Okay. And now, again, I'm sorry, I'm not sure at this point if you're going to be able to see, but I got a mass of 8 grams and a volume of 8 mLs. All right, so this is actually great because if you are aware of water density of water, you know that it's right around 1 gram per milliliter. So that's really good. Okay, so now let's take a look. I want to calibrate this medicine cup. Okay, so I want to calibrate this medicine cup. And so I turn this on with the cup on top of it, and that is one way to tare this. And now what I'm going to do is I am going to fill it to the mark that says 10 mLs. And if it is 10 mLs, then that means that I should have 10 grams. Because I know that my pipette is really quite accurate. This is an excellent example of, whoop, pipette didn't behave quite well there. I'm not quite at 10 mLs. So I will use my little tiny disposable pipette to try to add some more. Okay, now if you can see that, it is right exactly at 10 mLs. And it looks like I'm getting 10.1. Okay, so we'll say calibrating children's medicine cup. Okay, and the 10 ml mark equals 10.1 grams. So I want you at the bottom of this to write whether or not you believe that this is a good and accurate representation. Think about accuracy versus precision. So is this a good and accurate measurement for this? And that's it for lab 1. See you in recitation.